Hello everyone and welcome to day 18 of the Jamb Physics in 40 Days series. Now this series is brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you will be able to gather all the necessary skills and tools that will help you to ace Jamb Physics. So if you are preparing for the Jamb exams and one of the subjects that you have selected to write in that exam is physics, then this video is specifically made for you. So trust me, you do not want to miss any video in this series. So we've been able to make a video per day from day 1 up until today, which is day 18. So please check out those videos from day 1 to day 18. Do not skip any one of them. They are very essential to ensure that you get all that you need to do well in the Jamb Physics. So please check it out and follow it religiously. In each of the videos, we've been able to look at the individual topics that we have in the Jamb Physics curriculum. And as addition to giving a crash course on those topics, we also solve multiple past questions on those individual topics. So please check them out. And in case you have any question on any of the videos at all, please make a comment with your questions in the comment section of that particular video, and we will definitely attend to every one of your comments. And also, to keep your practice going, don't forget to download the Exam Fund app. We're going to drop the link to download that app in the description box of this video as well. So please click the link, download the app, and make your learning experience very much fun. Now, to the business of day 18, we're going to be looking at the structure of matter and kinetic theory. Now, what Jamb expects every candidate to be able to do as far as this topic goes are listed here in the objectives. So number one, you should be able to differentiate between atoms and molecules. Now, please take note, when we refer to atoms, we are looking at the smallest particle of an element, whereas a molecule is the smallest particle of a substance. So a molecule can comprise of two similar atoms or two or more dissimilar atoms. So you can have a molecule of two oxygen atoms, you can have a molecule of two hydrogen atoms, and so on. They are molecules. And you can also have a molecule that consists of two or more atoms, like that. So that's the difference there. Where one is looking at the smallest particle of an element, the other is looking at the smallest particle of a compound, right? So the smallest particle of a compound is what we call a molecule, while the smallest particle of an element is atom. So that's the difference there. You should also be able to use the molecular theory to explain Brownian motion, diffusion, surface tension, capillarity, adhesion, cohesion, and angle of contact. Now, all of these are evidence that goes to show that every substance comprises of tiny particles known as molecules, right? And there are some practical evidence that show us these things from things that we can see even around us. Now, one of them is what we call the Brownian motion, originally observed by Robert Brown when he was suspending pollen grains on water and was trying to observe them using a microscope. Now, he suspended pollen grains on water and he was observing them under the microscope, and he saw that those pollen grains were moving about in an haphazard kind of direction. They never had a particular direction. They were just going randomly across the surface of the liquid, even though the water appears to look calm. Now, you see, the water is calm, but yet what is suspended on the water is moving about randomly. So that caused him to deduce that definitely the molecules of the water must be vigorously hitting the pollen grains and causing them to move about randomly. And you can do this experiment also within the house. If you have what we call the lycopodium powder, you can suspend that in water. To make it more visible, you can add a bit of food coloring to your water and then observe it under a microscope. You will definitely see that random motion too. It's a simple experiment that can be done in the laboratory. And if you haven't, you can also check out videos on it, and then you can check out more explanation on this topic on our channel. Now, we also have the case of diffusion. One very good example of this case is when you put the bromine solution into a jar and then leave it. After a while, you observe that the entire jar is going to be filled with brownish kind of vapor, which is actually bromine vapor. That tells you that the particles or the molecules of bromine has diffused about. The same thing is what happens when you take your perfume or your spray at home and then you spray it. You see that within a short while, the entire room is going to be saturated with that aroma from your perfume. That tells you that the little molecules of perfume that you just spread now have been able to move about because they are free to spread about the space in your room, which goes to show that that spray you have in your hand consists of tiny particles known as molecules that are free to move about because they are in the gaseous state when you release them from the can. Now, we also have the case of surface tension and capillarity and adhesion. For more explanation on this, please check out our video where we critically look at the structure of matter and kinetic theory and explain each of these practical evidence. So please, you don't want to miss it. Check out the video. Now, in this case, we have, you also should be able to examine the assumptions of the kinetic theory. There are about 4 to 5 assumptions of the kinetic theory depending on which aspect you're looking at. One of them is that yes, they consist of tiny particles known as molecules. It also assumes that those molecules are moving about in constant random motion. And another assumption is that as they are moving about, they collide elastically with each other and with the walls of their container. Another assumption there is that the average kinetic energy of the molecules of that substance is equivalent to the temperature of the substance. Now, these are the assumptions made by the kinetic molecular theory. And in addition to that, it also says that the volume of gas molecules is negligible compared to the volume of its container. This is because every gas fills up the entire volume of the container holding them. So it doesn't matter the volume of the gas you put in a container. It's just the volume of the container that really matters. The volume of the gas itself is negligible when you compare it to the volume of its container. And then finally, Jamb expects that you should be able to interpret kinetic theory and then the pressure exerted by gases. That's where you look at gas laws such as Boyle's law, Charles' law, pressure law, and the likes. We have talked more on this even in our previous videos for preparation for Jamb. So please check them out once again to be sure. If you have any question, please don't forget to put them in the comment section. And then we should also be able to explain a change in temperature and evaporation. I did mention that one of the assumptions of the kinetic theory is that the average kinetic energy of the molecules of a substance is equivalent to its temperature. So you should understand that equivalency between the average kinetic energy of the molecules and the temperature of a substance. That's what this statement actually means. So having gone through all of this that is expected of you, we should be able to use this now to solve questions on the topic. So we'll be looking at past questions on structures of matter and kinetic theory from Jamb. So please get your materials ready and please don't forget to like, share the video and also subscribe to the channel. Now let's solve some past questions. This question has been repeated in quite a number of years of Jamb exams and most recently in 2020. And the question says, a few grains of table salt were put in a cup of cold water, kept at constant temperature, and left undistributed. Now, by left undistributed means it wasn't stirred, right? Now, eventually, all the water tasted salty, and this action is due to, now you see that when you add the quantity of salt to the water, initially, the region that's supposed to taste salty is within that part where the salt was added, right? Now, over time, the salt itself will dissolve and then spread throughout the liquid by itself. Now, when something is spreading throughout a space from a region of where it is most concentrated to where it is least concentrated, that is what we know as diffusion. That is the spreading out of molecules of a substance from the region of high concentration to regions of low concentration. So in this case, the answer is diffusion, option D. In the molecular explanation of conduction, heat is transferred by. Let's kill three birds with one stone with this question. So in this case, we are considering conduction. However, heat transfer can occur by conduction, by convection, and by radiation. Now, heat transfer by conduction involves the transfer of heat energy in a material from molecule to molecule, where the molecules are vibrating more rapidly and then they transfer energy from one to the other, from the hotter region to the cooler region. And then in the case of convection, we see transfer of heat in a material by the actual movement of heated fluids from the region of hotter to the cooler regions. And then for radiation, we see transfer of heat whereby we use the invisible electromagnetic waves. That is, heat is transferred using the electromagnetic waves without directly hitting their intervening particles between them. So these are the three ways by which heat energy can be transferred from one point to the other, or what we call heat transfer, right? But in this case, we are looking at the molecular explanation for conduction. Now, let's look at this the options that we are given here and see which one actually describes conduction. So we see that the heat is transferred by, is it by free electrons, by free atoms, by free molecules, or by free solids? Now, we are considering materials that are made up of tiny particles called molecules. Now, because of the rapid vibrations of these molecules, we say the molecules are free. So when they transfer energy from molecule to molecule, from the hotter to the cooler region, that is conduction. So the answer here is option C. The force between the molecules of a liquid in contact with that of a solid is, now we are looking at the force that exists between a liquid, the molecules of a liquid, and the molecules of a solid. Now please take note, in this case, we are actually considering that it is adhesive force or cohesive force. Now, to always remember, know that when you have adhesive, right, you are looking at two different molecules, and then cohesive is molecules of same substance. So when you're looking at the force that attracts or that binds molecules of different substances, we're looking at adhesive force. But the force that binds molecules of the same substance would be cohesive force. So in this case, since we are looking at that of a liquid and a solid, then it is adhesive force. So our answer is A. Which of the following concepts is not an evidence of particles' nature of matter? Now, there are different questions, like this same question appears about 2 times that I've seen so far, but with different options where they have just one difference rather in their options. In this case here, we are having options such as diffusion, Brownian motion, diffraction, and crystallization. And I believe there's another question I saw where these options are the same except for option D, where we then have esterification in place of crystallization. Now, in these two different questions, the answers are different. Now, and I'll explain why. Now, in this case, we have 4 different things to pick from. Which one of them does not give an evidence to the particle's nature of matter? That is, which of them does not explain that matter consists of tiny particles called molecules? Now, when we consider diffusion, that is when a particular substance spread out from the region of higher concentration to region of lesser concentration, like in the case of perfume, the spreading out of your perfume when you spray it at one point. Another case is like when you put the bromine liquid into a particular jar, it spreads out, the bromine vapor is going to spread out throughout the entire jar. Those are cases of diffusion, and they explain that bromine in that case consists of molecules. Same thing with Brownian motion, where when you suspend tiny particles on liquid such as the lycopodium powder, for example, if you observe it suspended on water, you see it moving about in a haphazard pattern, just like Robert Brown also observed when he suspended pollen grains on water and then theorized that the molecules of waters must be knocking around those tiny particles of pollen grain. So they explain molecular theory as well, or they give evidence rather to the particles nature of matter. Now, we are left with these two options. We have diffraction and then crystallization. Now, diffraction is used mostly when we're explaining waves, right? Where a wave moves through a tiny space and then spread out from that point. And then crystallization is when you are trying to recover the solid structure of a particular material that has been dissolved in water. Like when you dissolve salt in water and then you try to recover the salt particles in its solid state again, you go through a process known as crystallization. Now, this explains more about molecules than diffraction will do in this context. So this is why in this particular case, our answer is going to be option C, because option C is the one that describes molecules less of all the four things that we have here. However, when the question is reversed, the options are changed such that crystallization is then replaced with esterification. Because diffraction still explains a bit of molecules, because there's no how you describe waves without the particles that are actually vibrating in that wave. For that kind of a question, you will choose esterification as your answer. But in this case, we're going with diffraction as the one that describes the particle nature of matter list of all these four options that we have. Mercury, which is spilled onto a glass surface, forms ball-like shapes because now when you spill mercury onto a clean glass and do the same thing with water onto a different clean glass, now what we will see is that the water will stick to the glass while the mercury will form a ball-like shape on the clean glass. Now, it's due to this reason. In the case of mercury, the cohesive force between the molecules of mercury is greater than the adhesive force between the molecules of mercury and the molecules of the glass. So meaning that the molecules of mercury are going to stick together more than they will want to stick to the glass, which causes it to have that curvy meniscus like that, such that it's forming that ball-like shape, because it is refusing to cling to glass but rather preferring to cling to their individual molecules even more tightly. And the reverse is the case for water, as water has more adhesive force than the cohesive force, meaning water wants to stick to other materials more than the molecules want to stick together, which is why you see that water wets glass while mercury does not. So what I've said now, we just need to check the options and see which one describes that. So A says mercury is a metal. This does not explain that. Now B says the cohesive force between the molecules is greater than the adhesive force between the mercury and glass molecules. Now this is exactly what I have described, so the correct option is therefore B. Before I go on to answer this question, please, if you're yet to subscribe to the channel, I want to implore you to please do so. It's only going to take a second of your time. And when you subscribe, you're helping us to be able to make more helpful content like this. So please help us to reach many more others who want content like this by subscribing to the channel and also sharing and liking the video. Please ensure you do this. And if you have any question at all concerning what we are doing, or if there's any question you came across while studying and you like help with that, please put it in the comment section and we will definitely attend to every one of your comments. So keep them coming. Now, to answer this question, it says palm oil from a bottle flows out more easily after it has been heated because now we know that palm oil is a viscous fluid, and which is why when it cools down, it is more difficult to pour it out of a bottle. It becomes very much viscous, more like a semi-solid, right? And in order to reduce this viscosity, one way we reduce viscosity is to apply heat. So in this case, you see that they've applied heat, and which is why it is flowing out more easily. So they have reduced viscosity. And viscosity is just friction between the layers of a fluid. So that is basically what describes what this question is asking of us. So let's look at the option and pick the correct one. Option A says molecules are given energy during the heating. It does not describe what we've just explained, so we go to B. B says friction between oil layers is reduced. Remember, I said you reduce viscosity, and viscosity is friction between the layers of a fluid. So therefore, that will be our answer, option B. The net movement of solvent molecules from a region of high solvent potential to a region of lower solvent potential through a partially or semi-permeable membrane is referred to as. Now, we can easily twist this question and just change some things there and then make the solvent, in this case, water, right? So if we are saying the movement of water from a region of high concentration to low concentration through a semi-permeable membrane, and then just like that, it makes the question very easy. Now, however, it's easy to just distinguish osmosis from diffusion by just using the semi-permeable membrane as part of your definition. So in this case, the answer is osmosis. So we go with option B. Which of the following statements is not correct? So let's go over the statements and then we see which is correct and which is not correct. So the first statement says Brownian motion is an evidence of particle nature of matter. Now this is one of the things we've been mentioning since the beginning of this video. And yes, one of the evidence of the particle nature of matter, or one of the evidence that matter is made up of tiny particles, is the Brownian motion. So this statement is true and it is correct. Now B says atoms combine to form molecules. I did mention this at the beginning of the video, that we have atoms and we have molecules, and what differentiates them is the fact that atom is the smallest particle of an element while molecule is the smallest particle of a substance. And I did mention that a molecule can be formed by the combination of two or more atoms. That is, when two or more atoms come together, you form a molecule. And you can also have different atoms of different elements coming together to also form a molecule. So yes, statement B is also correct. Now, statement C says the molecules of matter are not in constant motion. This is false, because on the contrary, the molecules that makes up matter are always in a state of constant random motion. So statement C is not correct. Now statement D says matter is made up of molecules. That is the first assumption of the kinetic molecular theory, and it is true. So the answer in this case is option C. The action of blotting paper on ink is due to, now when you have a blotting paper and dip in ink, you observe that the ink is going to move up the paper by itself without application of any external force. Now this kind of phenomenon is called capillarity, which is the tendency of a liquid to move up narrow spaces, to either fall or rise in narrow spaces rather, without the application of external forces. It's the same thing that you're going to observe when you put narrow capillary tube into liquids. You see that the liquid is going to rise or fall depending on the kind of liquid you are working with. Like in the case of water, it is going to rise, but in the case of mercury, it is going to fall. So those are cases of capillarity, and the same thing applies to blotting paper, where ink moves up the narrow spaces in the paper due to the action of capillarity, or what we say called capillarity action or capillary action. So the answer to this question would be C, capillarity. The differences observed in solids, liquid, and gases may be accounted for by. Now, when you consider the options here, we see things like relative mass, melting point, spacing, and forces acting between molecules, and the different molecules in each of them. Now, take for example, water. When it freezes at solid state, we have it as ice. In its liquid phase, we call it water. And then in its gaseous state, we call it steam or water vapor, right? Now, the molecules there are still the same. They are still the same. But what actually differentiates solid ice, liquid water, and gaseous steam or vapor is the way the molecules are arranged. Now, when we consider arrangement of molecules, you see that when the average position of the molecules remain the same. That is, you see that the molecules are tightly packed and forced to stay in one position, then you are referring to solids. Right? When the molecules remain packed such that they have a regular shape, a regular volume, that is solids. Now, when they do not have a regular shape, but they can still have a regular volume, then you are looking at liquids. This is because the molecules are slightly freer. The force that is holding them together is no longer strong. By the way, in the case of solids, the force holding them is strong cohesive force. But for liquids, we have weak forces holding the molecules together, which is why you see that they are able to flow even though they are not totally free to move about. So that case, we are looking at liquids, right? And then when the molecules are completely free such that they can move about without any hindrance, then you are looking at gases. So when you are describing them based on the way the separation between the molecules are, how free they are from each other, how far apart they are from each other, and also looking at the kind of force that hold them together. Remember, in the case of solid, I said they are held by cohesive force. In the case of liquid, they are held by weak van der Waals forces. And in case of gases, the forces holding the molecules are negligible. There is no force holding them together. So in that case, that is what you can use to describe solid, liquids, and gases. So we'll be looking at option C, which talks about the spacing and the forces acting between the molecules. If a tube of small radius opened at both ends is placed in a liquid, the liquid will, so we are looking at a case of a capillary tube dropped in a liquid. Now, I did mention that capillarity is the tendency of a liquid to rise or fall in a narrow tube, right? And I did mention, like in the case of water and mercury, I mentioned that water will rise, the level of water will rise, while the level of mercury will drop. Now, this is because of their force of adhesion, right? So in the case of water, it has more force of adhesion, so it's wet glass, which causes it to rise. But mercury does not wet glass, and that is why it will fall. So in this case, we're going to use that, what I just mentioned now, to answer the question. So what will happen if you put a narrow capillary tube in a liquid? Now, option A says the level will remain, the liquid will remain the same, will remain at the same level, irrespective of whether the liquid wet glass or not. Now, this is false because we have mentioned now that when it's wet glass, it will rise, but when it does not wet glass, it will fall. So let's go to B. B says it will fall, the liquid will fall below the liquid level if the liquid wets glass. Now, when the liquid wets glass, it's supposed to rise above the liquid level. So B is also false. Now, C says the liquid will fall below the liquid level if the liquid does not wet glass. Like in the case of mercury, it does not wet glass, so it will fall below the liquid level. So that is true. And then D says rise above the liquid level if the liquid does not wet glass. If it does not wet glass, it's supposed to fall below the liquid level. So back to option C. So the correct one is therefore C. This question says from mass, density, temperature, and nature of substance, which of the above affects diffusion? So let's explore. Now, in the case of mass, when an object is going to be diffused, the heavier it is, the less the rate at which it is going to diffuse. So that is, the less heavy substance are going to diffuse faster than the more heavy substances. So mass definitely affects diffusion. Now, the same thing is the case with density. The more the density, the lesser or the slower the rate of diffusion. So these two will slow down diffusion as it gets more and more. Now, in the case of temperature, the higher the temperature, the faster the rate at which substances are going to diffuse. So it also affects diffusion, meaning that higher temperature aids it to diffuse faster, while lower temperature will reduce the rate at which the substance is going to diffuse. And then finally, the nature of the substance. So natures of substance such as polarity and the likes can affect how diffusion occurs. It can affect the rate of diffusion. So we see all these four can affect how fast or how slow a substance is going to diffuse. So the correct option will be the one that combines all the four of them, and that is what we see in option D. So we go with D. Blowing air over a liquid aids evaporation by. Now, when you blow air over an open liquid, it actually increases the rate of evaporation by decreasing the vapor pressure, thereby allowing more of the molecules of the liquid to be able to escape into the gaseous state. So the answer is that it decreases vapor pressure. So we go with option B. In this question, we are told that water does not drop through an open umbrella of silk material unless the inside of the material is touched. Now, we are then asked, this is due to what? Now, when water is dropping on a silk material umbrella, what happens is that the surface tension will cause the water to just be as tiny drops on the material of that silk umbrella. Now, the moment you touch the inside of the umbrella, you are disturbing the surface tension. And the moment you disturb that surface tension, it will then cause that water drop to be able to seep through the material of the umbrella. So the answer in this case is surface tension. That is option D. The phenomenon whereby the water droplets in the atmosphere combines with dust particles in the air to reduce visibility is. Now, some of the statements in this definition is similar to what creates what we know as mist and fog. However, there is a difference between mist and fog. Now, take note, mist occurs when the relative humidity is low. Is high rather, when there is more humidity. When there is more humidity is when you have mist, and then mist occurs at a level that is very close to the ground. And this mist does not happen at high altitudes, at very low altitudes. So that means that for these cases, we are looking at the one that will cause visibility to be reduced. It has to happen at a level that is at least above the high level of a person. So in this case, we are considering fog rather than mist. So what you see, that tiny cloud, the kind of cloud formations you see that covers the atmosphere, makes it difficult for you to see, is what we call fog. While the one that happens on the top of lakes and things like that, where it looks as if there is a little bit of cloud over water, is what we know as mist. So you see the difference between them is the altitude at which they occur and also the amount of humidity you have when they occur. So for this particular question, we're going to focus on the part that is reduced visibility and then go on to choose option D, which is fog. Now, folks, you can practice with many more questions by trying out the Exam Fun app. The link to download the app is going to be added to the description box of this video. So please click the link that will take you to either the Google Play Store or the Apple Store, depending on your device, and then you can get to download the Exam Fun app. It's a very interesting app that makes your learning experience fun, more like a game setting where you get to solve multiple questions in your preferred subject at different levels. So please try it out today and spice up your education, make it more fun by trying the Exam Fun app today. And also don't forget to like, share, and subscribe to the channel. Please subscribe to the channel. When you do this, you are helping us to be able to make more helpful content like this, and we really want to continue to make content like this that helps so many people. So please subscribe to the channel and also hit the notification bell icon so that you get alerted every time we put out a new content. Thank you very much for following this series. I'll see you in the next video.